Alright, today we're going to be working through systems of equations and solving systems of equations. We've got three methods that we can use to solve a system of equations, but again, it's what we're looking at with the type of equations that we have that are going to direct us to either graphing, substitution, or elimination. But let's just get started on the basics of a system. The systems that we're going to be working with are going to be two equations. Something like this. We've got y equals 2x plus 4 and y equals negative 3x minus 6. And in solving a system, what we're looking for is an ordered pair. Remember, that x comma y, that satisfies both equations. And what that means is, let's just say I get a point of 1 comma 2. When I put in the 1 and the 1 in for x, or the 2 and the 2 in for y, you're going to get a true statement for both. So make sure that when you guys are solving these, it has to work for both. As a visual, which we're going to get into graphing, you're going to notice that that ordered pair is actually the intersection of these two equations, or two functions, and in this case, two linear functions. So let's just get started. We're going to start off with the graphing method. And remember, think back, all those ways for graphing a linear function. We're just going to start off with the first one, y equals 2x plus 4. So we have our xy chart, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So let's start it off. We've got to think about what form is this in. Okay, all right, it's y equals slope-intercept form. Remembering, 4 is going to be that starting point. Can you think about what that is? Right, it's the y-intercept. So we're going to start off with that y-intercept of 0, 1, 2, 3, and 4. And now, again, that other piece to graph, we got to go to this guy right here, which is the slope. We slope of 2 over 1, or the rise of 2 and a run of 1. In this situation, I'm going to go up 2 over 1. Okay, I can continue up into quadrant 1, but I'm actually going to go into quadrant 2 going down 2 and to the left 1, down 2 and to the left 1. And I have my first piece of this system. I'm going to use a different color just to designate this here. I'm going to apply the same approach. It's in slope-intercept form. I've got a y-intercept of negative 6. I have a slope of negative 3. Notice, positive slope, negative slope. You've got to think of how that's going to affect the direction that the line is going to be going. But let's just see what's going to happen. So we go to the negative 6 as the y-intercept. 1, 2, 3, 4, 5, 6. Now, down 3 over 1, 1, 2, 3 over 1, is going to take me further into quadrant 4. It's not really going to help me find this intersection. I actually want to go towards the other line. So I'm going to go up 1, 2, 3 over 1. Up 1, 2, 3 over 1, and bingo. I have our point of intersection. And just as a reminder, notice the positive slope of 2 going up from left to right. Negative 3 slope is going down from left to right. And we have this intersection, this ordered pair right here, which is, again, the x value of negative 2 and our y value of 0. Let's just see if it works. So we're going to plug this in. Again, remember, it needs to be a true statement for both. So I take that y value of 0 equals 2 times the quantity of negative 2. Sorry, little mistake there. Plus 4. So it's 0 equals negative 4 plus 4, 0 equals 0. Okay, that works for that one. Now let's just see if it works for the other. So we're going to plug in a 0. That's going to equal negative 3 times the quantity negative 2 minus 6. And as you kind of see, we have a positive 6, negative times a negative. And we have 0 equaling 0. So that does check out. Obviously, because I trust my graphing skills, that was the right answer as well. All right, that's the first piece. I'm going to erase a little bit. Okay, now, what we have, I'm going to leave this up there so we have this. Now we're going to get into substitution. And this is the next piece. Making sure you guys are writing this down, remembering these two pieces. Substitution. Substitution. Alright. Now, the substitution method, what we're going to use is algebraic skills to find y value and an x value. But the big thing we're going to do is we have to substitute to get down to one variable in one equation that we can solve for, that we're going to then sub back in to get the corresponding y or corresponding x. Substitution. Since I have y equaling 2x plus 4 and y equaling negative 3x minus 1, and in this case the y's are the same, these have to be the same. Since they have to be the same, I know that this y value right here is going to be this y value as well. So I'm going to substitute negative 3x minus 6, and that's going to be equal to 2x plus 4. And you got to think also, yeah, it's just like where they meet, where they're, got some music going on, it's okay. But yeah, so we've got, and we're going to use algebraic skills to go ahead and solve. So what I'm going to do is I'm going to add 3x, because I need to isolate my x value. I add 3x, and I'm going to subtract 4. And what I'm left with is negative 10 equals 5x. We've gotten down to one variable, as we did here. So I solve for that, and I get x equaling negative 2. Ta-da! All right. So now, all right, I got one of those one of the points, or one of the, I've only had the x value for this, so I need to get the corresponding y. So what am I going to do? I'm going to take this x, and I can pick either one to sub it back in. So I'm going to go with the first one. So I sub that back in, and I get y equals 2 times negative 2 plus 4. And you have y equaling negative 4 plus 4, y equaling 0. Our x value of negative 2, our y value of 0, and to finish it off, to write the answer in proper notation, I'm going to write it as an ordered pair. The last piece that we're going to do, as far as for systems of equations, is going to be the elimination method. Okay, with the elimination method, I'm going to go ahead and erase this. Okay, I'm also going to erase the graphing. Okay, remembering that answer was negative 2, 0. Elimination is, again, along the same lines as substitution, is getting rid of one of the variables through algebraic means to get a one variable equation which I can solve for, and then sub it back in to get the corresponding value. All right, so now I'm going to go ahead and write these equations a little bit bigger. Now, what we're going to use is we're actually going to be adding these equations together. I'm going to add this area, I'm going to add these, and I'm going to add these. But we got to play around with it to get what we want. We need to eliminate. If I add this together, I'm going to have 2y equaling x minus 2. Still two variables. What we need to get is called additive inverses. So notice I have the same coefficient here of 1 and 1. But an additive inverse, instead of being y and y, I need y and negative y. So when I add them together, they're eliminated. So what could I do to this whole entire equation to turn y into negative y? I don't know, what do you think? If you chose negative 1, multiplying that by the entire equation, you're right. So I'm going to multiply this entire equation by negative 1. So I'm going to rewrite this first one. I get y equals 2x plus 4. And then I'm going to bring this guy down. Negative 1 times y, I'm going to distribute it across. Negative 1 times negative 3, that's 3x. And negative 1 times negative 6, that's a positive 6. Now, additive inverses. I go ahead, I'm going to add these two equations. Y plus a negative y, 0. 2x plus 3x, 5x. 4 plus 6, it's a positive 10. And here I've got an equation, one variable, which I can solve for. So I'm going to go ahead and bring that 10 over, solve for x, and I got x equaling negative 2. Same as the substitution and graphing method. Then I take this. A lot of us might stop here, but I need that corresponding y. I plug it back in. And I'm going to go, let's go into the other equations. Since we did substitution, we used the first one. Let's just check it out. So we have y equals negative 3 times negative 2 minus 6. Y equals positive 6 minus 6. And sure enough, our algebra has shown us that the same corresponding ordered pair. So we have solved this system 3 different ways. And we'll get into different ways to attack the problem based on what you're looking at later on.